Hey, I'm Anna May, and this is my template chapter review over chapter 13, Changing Earth's Climate. Basically, overall, this whole chapter was about how our human activities, especially those that include the emissions of greenhouse gases, like carbon dioxide, are the main cause of our climate change. All these factors led to the disruption of the balance of our energy, which we learned a lot about this week, and how that's what impacts the climate change and makes it go through all the funky stuff that it does. We learn about how the natural forces that we'll talk about more later towards the end of this template, how it has very little effect on like the climate change and stuff. It's mostly just like by the things that we do. And there are feedback effects that are in effect to try to help stabilize our balance of energy. And this, like certain things like cloud formation and even more plant growth, just tries to help to stabilize our energy balance. We are actually also presented with a success story of of cooperation internationally with this that was proven by scientific consensus called the Montreal Protocol. This brings me to my first section. This section is called climate forcing. Um, Basically, this section just talks about climate forcing, which we learned a lot about this week. It was one of our vocabulary words, and how it's just basically anything that upsets our balance of energy. And overall, this can affect climate change. Like we've all, basically, this whole class, we have talked about this kind of stuff. Um, and it could increase other things like solar energy, greenhouse gases, changes in surface albedo, and even matter from volcanoes. All of all of the terms that I just said are examples of climate forcing, and scientists can actually now use computerized models to match these processes to see how that we are affected, like the climate and just the environments and everything is affected by these changes. And we learn about like not positive and negative. Of course, positive forcing causes like warming in our temperatures, and negative forcing will lead to the cooling of our temperatures. Um, which brings me to our next section, which is climate sensitivity. Uh, this one goes along with climate forcing. I learned that in with our spelling word, or not our spelling words, our vocabulary words as well. This one just talks about like how scientists can use like what if analysis and climate sensitivity to predict these changes in our temperature. Um, that could that could be affected by the different carbon levels. Even if this were to stop, it would continue on just because it will warm until it's balanced again and equals out. It'll meet at equilibrium. Um, this is just a simple way to see how our climate reacts to the climate forcing. It's just a better way and simpler way to put it into terms like that. It's defined as a global average of temp, temp global average temperature, which is expected from the double atmospheric carbon. Scientists can also use these computerized climate models to get data from earlier climates and estimate like what's going to happen, how it's going to happen, and like there's just a lot of new technologies have come to bay, and it just I think it could help in a lot of ways because just think of all the technology we have now and like how more advanced we are and how we can predict things and just know like have a better understanding of what's happening and when it's going to happen and how it's happening just because of our technology and how it has evolved. Um, for all of this to equal out and meet in the middle, meet at equilibrium, become more balanced, it would take so many years, keep in mind. Um, But our climate here on Earth would get to the point where it just like equals the gas concentrations or gas emissions, greenhouse gas emissions. So then it would equal out and it would stabilize our energy and just the temperature, everything would be stabilized. This brings me to feedback effects. This one just talks about how our climate uses feedback mechanisms to keep its balance, of course, like what I was just talking about. But it does tell us a lot about negative feedback and how like higher carbon plant growth and more clouds to reflect the sunlight. This is just like the mechanisms I was talking about earlier when I was giving you the overview of this chapter. Um, our climate system contains like different interactions. Like there's so many like with the surface, atmosphere, sunlight, biological systems, chemical systems, geological systems, and even human society. Um, it's just like one simple little change, like one little change can lead to so many more, be like a domino effect. Like if one thing happens, so many more can has a possibility of happening. That's just like how it is. And and then this is what leads to giving us feedback effects. A negative feedback reduces the magnitude of the initial change, so like within a system. So, like for example, like increased radiation on Earth's surface could cause our temperature to rise. Um, so yeah. Um, our next section is it's called natural or anthropogenic forcings. This section really just ties it all together, like in the sense of our climate. Talks about like different aerosols and greenhouse gases and how they played a big role in our climate change, and it has affected our balance of energy. Okay, aerosols, I think of like hairspray, like cans like that, and how I remember like years ago when I was in like middle school, they were talking about like the hole in the ozone and how everything was not going too good with the ozone. And we'll get into that more later. Well, it's like right here in a minute. I used that diagram. But I remember that like in middle school because in the diagram it does say in 2006. So, but I was only like 2 years old at that time. So, um, maybe it was just it's still a big topic in like 2012, 2013, those times I feel like. Um, Anyways, this one just talks about the aerosols and greenhouse gases, like I talked about, and how they affect climate change and our energy balance. And it talks about the biggest factor is us humans to the climate change, like our use of energy. And natural forces have really little to no impact on it, really. The impact of human activities are measured all the way back from pre-industrial times to now, and of course, it has went up insanely probably because like think of all the industries now that like produce all this carbon and back then there wasn't half as many um industries and like industrial we had like the industrial revolution, so like of course it's going to be so much more now. Talks about how anthropogenic factors are the main, like that's what they really touch base on, and like it's and how they affect our climate change. And natural forces like volcanoes have really little effect, like I said, in comparison to our human energy use. This brings me to my first diagram. I'll zoom in so we can see it. And I just like this one because it showed all the different sources that play into the carbon emissions and climate change. And of course, like we talked about over the course of the last, I think this is week 13. Um, this diagram right here. It shows us that the top three providers in this, in our carbon emissions are coal being the most, oil next, and natural gas. They go from 33%, 29% to 19%. The next one is land use. That one surprises me kind of. How can land use? I'm guessing land use is like used with industries and stuff. I'm not sure. But that's how I would take it with land use. But it's kind of crazy to me that gas and land use are really close in percentages of that nature. Next, I'm going to talk about. Whoa. This is the diagram that I was talking about earlier. This one really interested me because I had never really seen like a diagram of the ozone and like what it actually like looks like per se. But this was a picture taken by NASA, so of course in space. And this was in 2006. Like I said, the green being the ozone, and then the dark purpley blue right here. And this is Antarctica, the continent. Yeah, I think it's a continent. um, but it just shows us how big the hole was at this point. This was the greatest that the hole had been in history. So this was its biggest point, which was in 2006. Like you have to put this in comparison. This is like a whole like continent, or yeah, and the hole in the ozone was bigger than that. So like that has to be a problem. I'm not. So I mean, I don't know. That's insane to me. I never knew that it was like that big. I didn't know it was that big of a deal until like this past week. This brings me to my last couple sections. This little box, the science meets policy, and it's about the Montreal Protocol, the one I was talking about. And it gives us a lot of information about it and how it is a good example of like a successful international cooperation and how it was driven by scientific consensus, and how it really led to a lot of benefits of the environment. This whole protocol was driven by discoveries in the 1970s about chlorofluorocarbons, or CFCs. These actually destroy the ozone. And President Ronald Reagan of the United States, actually praised this protocol in 1988 because of its cooperation on and consensus on a international level. So that was probably good for the countries to like band together and agree. Actually, in 2012, all nations agreed on this, and it became the best accidental climate treaty. There was phase outs. I kind of jumped. There were phase outs of these products, and the ozone actually began to recover in by 2020, and this led to like replacements for these types of products. And this actually prevented. This is the craziest part. This is my favorite information that I learned the whole chapter, but it says that it prevented 2.3 million skin cancer deaths. I didn't. How can a chlorofluorocarbon cause that many? You know what I mean? That's insane to even think about. The last section is called Carbon: A Closer Look. So it's just basically talking about how carbon is the biggest man-made contribution that we have to climate forcing, and it just leads to more climate change. And carbon sinks they actually do remove carbon from the atmosphere, but this is all threatened by climate change. Human activities like our energy use and industrial growth is the biggest factor of our climate change, and like the natural carbon cycle involves all this carbon to move through these different reservoirs, but the but this we disrupt the cycle with causing the problem with climate change. So everything's just threw off a loop, and carbon sinks are like oceans and forests that help to move the carbon from the atmosphere, but it's still all up in the air and questionable, of course. This brings me to my last diagram. And this one I just thought was important to this section because it shows, whoops, I moved it. It just shows about how carbon went down for the first 200 years of this 1,000 years that they went off of. Not, uh, I'm not sure, but this one just talks about like over 1,000 year period, and it went down for the first like 200 years it looks like, but then it just like evened out and stabilized right through here. And carbon still remains in our atmosphere, even though it did go down. It's still there. So I don't know. It's a lot to think about, really. It's like interesting to try to learn about and deepen your understanding on. And I think that's what this chapter done for me. But thank you.